Good day to all. Today I'm going to focus my attention on these new valvular conduits, in particular the difference between these diodic pipes versus a Tesla valve, and we'll show you an application in which these valvular conduits are useful. First, let's, as you can see on the video, we have the Tesla valve on my left and these devices that I've called diodic pipes on my right. And the substantial difference between these two devices, as you can see, even as you can imagine, for whoever has seen a Tesla valve, is that the Tesla valve itself is hefty, bulky, and occupies too much space. And this has limited its application. In fact, in recent years, applications have been limited to microfluids. Another factor is that it is rigid in its design. This means that in order to have different values of diodicity, there's not much to do than arrange them in parallel, arrange them in series. Diodic pipes, instead, are extremely versatile. There are no limits in application, from microfluid to terafluid applications, and we'll see later on. Diodic pipes also offer more options and more solutions. As you can see, we have different profiles, and it's easy to insert them in any kind of system, hydraulic system. Applications. Okay, one common application that we've noticed even on the tests we made is the problem that usually is in any kind of system, and that is that of the hydraulic transients, hydraulic shocks, you could call them, or also the hammer effect. What are these? These are substantially pressure. It's only a pressure surge due to a sudden closing of a valve, startup operations, shutting down of a pump, the sudden condensation of steam vapors. And as I said, it's not limited to only water pipes, but also these problems occur in fire protection systems, sewage systems, steam generating facilities, oil pipelines, transfer of condensed gases, chlorine, ammonia, liquefied natural gas. And the consequences are devastating sometimes, mostly, since the effects are not only pipe ruptures, joint leaks, but they can bring also to fire, explosions, and with the risk of life of workers, and even depending how big is the plant, to the population. The advantages, therefore, of the diodic pipes are, one, the fact that these valvular conduits, these don't have any moving parts, just like the Tesla valve. This means simply that no wear and tear, no corrosion. And another factor is that these devices are passive components. They don't need no external energy source. That means no energy consumption. Therefore, operating and maintenance costs are reduced. What is important, however, is that all kinds of hydraulic systems reach a higher level of safety and reliability. For example, pumps are guarded from backflow. These pipes help keep water within pipes for no self-priming centrifugal pumps. Pressure relief valves that are components of any kind of system are less strained, and the demand of performance on these valves can be lowered. In other words, all components and equipment that are part of the system are protected. And last but not least, a high level of personal safety in management of the system in all cases. So stay tuned, and we'll talk about other applications. Thank you.